all the topics on last session we have discussed about OSP of single area and OSP of multiple area and OSP of complete terminology of OSP of we have completed and OSP of configuration also have done. And today concept let me continue with OSP of in LAN. Especially the topic is here what OSP of in LAN. Like R1 router, R2 router, R3, R4, R5. Printing mistake here. It is let's say this is R4 and it is a R5. So 5 routers in one switch. One switch is connected. The same LAN. Number of devices. Generally, how the topology is a R1 in one location, another location, right? But this concept is if all the routers, number of routers in one LAN, in one switch, how OSPF is working. That we'll discuss clearly now. Like what type of topology is this? Star topology. Because number of devices are connected to one centralized device. Based upon our SBI example, where is the main office, main head office, Mumbai? Right? Like in India wide, in one office, have a SBI branch. Now for this office, number of branches are connected. 1, 2, 3, 4. Number of. Like total, how many branches are available, guys, here for SBI? 14K. Like, do you think 14K routers are connected to only one router? No. Like, if you visit any like Mumbai office, they have a one network setup is there. Number of routers. Example, router 1, router 2, router 3, router 4, router 5, 5 routers in one office. R1, R2, R3, R4 and R5 in one office. Is one office, right? So these all routers from R1, number of branches are connected. In R2 also number of branches are connected. R4 also number of branches are connected. R5. These are the core routers, 9000 series routers, ISP routers we can say. So these all routers are connected to one switch. Now between all 5 routers we have configured OSPO. This type of network topology, this type of connectivity we call OSPF in LAN. OSPF in LAN. Now how OSPF is working in LAN, we clearly discussed it now. So do you remember, guys, the OSPF of 7 states? What is the first state? Sound state, initial state, two-way state, start, exchange, loading, and full state. These are the OSP of 7 states. Okay. So what happened here it is, this all routers as belongs to area 0, backbone area. Like from any one of the router, any update is came. Like R1 is country number of routers, right? Like any one router, if any link is down, what R1 is doing is going to update to all routers. R1 is going to update to what? R2 also. R1 is going to update to R3 also. Now what R2 is doing is, again is going to update R1, R4, R5, R3. See, actually R1, one of router, R1 router link is being failed. So what R1 will do is doing is going to send update to R2. sending update to R3, R4 and R5. Update is done. But after receiving R2, what R2 is doing is again the same update will send to R1 also, R3 also, R4 also, R5 also. In R3 again it will send. It's a broadcast happening in the LAN. So this is a task. More traffic is being generating. Broadcast happening in the when you configured OES in LAN. What's the problem is broadcast. Like number of times are updating. So to avoid broadcast in the LAN, to avoid this type of issues, what we are doing is we are going to choose any one of the router. Like one router has to update. Remaining routers has to receive the update only. So which router has to update means that router we need to elect. That router we call DR, designated router. So one router should be update to remaining all routers. That should be what? DR router, the designated router. It can be R1 or R2 or R3, R4, R5. Any router, any one router can be a DR router. So once DR elections is done, let's say example R3 has been elected. Now R3 only have to update to remaining all routers. Remaining all routers has to receive only update. Now R3 is a DR. R3 is going to update to all routers in the LAN. If any changes happen, R3 is going to update. If R3 is fails, I mean if DR is fails, then who will update? Example, like I am the senior faculty in Zoom technologies. I'm going to taking the classes, right? Sessions. If I am absent, if I'm not able to come, then what will do? Right. Like my colleague will be happen, right? My in charge, like what happened in the sixth or some last day, right? Similarly, same like here also, if DR fails, we require one more router to update it. So that router we call BDR, backup designated router. Okay, let's say example R2. Now R3 is a DR designated router, it has to update. Now R2 is a BDR, backup designated router. So when BDR will come in the picture, if DR fails, then only BDR will come in the picture, right? Remaining all routers we call DR others. So these election process we have to do it in LAN, OSP in LAN. So one router should be designated to update, and one more for backup for that router, and the remaining are what? DR others. OSPF will send the hello packets, right? So this hello packet will send the multicast messages by using which IP address, guys? 224 dot, not broadcast, multicast. Not broadcast, multicast IP address. 224.0.0.5. Not 1, 5, right? So OSPF will use one more multicast IP address, which is 224.0.0.6. Example, designated router is elected when OSPF routers are connected to the same multi-access networks. This is done to for what purpose, guys? This is done for what? Reduce the number of adjacencies being formed. If there is change in topology, initial router will be update only the DR and BDR and no other routers, right? So DR is done, will update the remaining router. What is the last point? If there is a change in topology, that initial router will only update to which router? DR router. Like as we have discussed in the topology, if R1 is connected to some topology or like number of routers, if something is been wrong, if there fails any changes, what Armon is doing is in R2, R3, R4, R5, which is the DR based upon an example here, R3. Like this initial router will send update to DR router. Hello, you are my leader, right? Like take my update. DR router, take my update. So routing has been down. What DR will do? Will send to all routers. So initial router not only sending to DR router, what initial router is doing is will send the copy to DR and BDR also. So initial router is sending update to what? DR router as well as what? BDR router. So BDR is keeping one copy here. So because whenever DR space has to send update packet, right? If there is no copy information, then how BDR will send the update packet? Getting the point? Like initial router will send the update to DR as well as what? BDR. But what DR will do? DR only has to send the update to remaining all routers. So BDR will not do that. Just receive the update and making a copy. Will update. Will only update the DR and BDR. And no other router. Then what DR will do? DR in the turn will update remaining. So BDR. For what purpose of BDR? Backup the DR will only receive update, but will not update the other routers. When DR down, then BDR will take the act of role of DR selection process. Other routers to DR is 224.0.0.6. DR to other routers is what? 24.0.0.5. Other routers to DR use what? 24.0.0.6. DR to other routers 24.0.0. Copy the previous slides. DR and BDR of DR and BDR rules. DR and BDR elections. Generally here, R1 router, R2, R3, R4, R5. Out of 5 routers, which is a DR router and which is a BDR router? So DR, BDR elections based upon what? Priority of the router. Router with highest priority will be elected as a DR router. Router with second highest priority is a BDR router. If R3 priority is a 200, in R2 is a 150, R1 is a like 90, R4 is 90, R5 is 90. Now out of 5 routers, which is a DR router? Why? What is DR? Why? Because highest priority, right? So DR BDR elections based upon what? Priority values. And one more example is by default for all routers, priority is 1. R3 priority is 1. R2 priority is 1. R1 priority is 1. R4 priority is 1. R5 priority is 1. So now you tell me guys, out of 5 routers, which is a DR router? Anyone. So tell me anyone. Out of anyone, which one can be a router? Not like that, here, so whenever priority is same, then what OSPF is doing is, now OSPF can consider the router with highest router ID. If R1 router LAN interface IP address is 10.0.0.1, if R2 IP address is 10.0.0.2, R3 is 10.0.0.3, R4 is 10.0.0.5, 4, R5 is a 10.0.0.5. Now, when priority is same, now what OSPF is doing is, like router with highest IP address is a DR router. And the second highest IP address will be what? BDR router. So now you tell me guys, which is a DR router in this topology here? R5 become what? DR router. And R4 is a R4 is what? BDR router, backup designated router. The thing is, R1 router have purchased in a 2020. Latest. Recently, I have purchased R1 router for my company. And R5 have purchased this router is in a, like in 2010. 10 years back, I have purchased this router. Even R2 have purchased in a 2020. 2019 have purchased. So this is my network topology. So as per OSPF now, which is a DR router, guys? As per this scenario, which is the DR router here? R5 is a DR. So means whatever the changes happens in your network topology, R5 has to update to all routers. It's taking the main role, right? So this router, when you have purchased in 2010, it means the OS is a older iOS version, and router performance also very slow. The router speed also very low speeds. Recently in R1, I have recently purchased which is a very high-end device, latest iOS version, very updated iOS versions, very high-speed device and very core process speed and memory speed is very high-end router. So now you tell me guys, compared to R1 and R5, which router has the best performance? R1, obviously R1, right? But what OSPF is doing is, so OSPF is going to decide R5 is a DR router. But I don't want R5 is a DR. I want to make R1 is a DR. And what we need to do now? don't want R5 is ZDR. I want to make R1 is ZDR. It's a very good performance. Manually configure. What will it configure manually? Yeah, this scenario, what will you do? So in this case now, change the priority. Configure the priority now. So which router you want to make a DR router? So that router should be configured with a highest priority value. So default priority is a all routers default priority is what 1, right? So I want to make R1 is a DR, then I have configured highest priority. Let's say example, I configured 250 is a R1, like 200 is a R2. The remaining all routers default 111. Right? So now if we configure again OSP of, now what OSP is doing is going to find out which router has the highest priority. So that router is being elected as a DR. So which router has the second highest priority, that is a BDR. Right? Say priority values are from 0 to 255 is the range of priority value. If any router with configured priority is a default priority is what, guys? Default priority is a 1. But if I make priority as a 0, R1 I have configured, like R4 I have configured as a R4 router I have configured priority is what? 0. If router is configured 0, priority if configured 0 means R4 is not going to participate in the DR elections. It's a null router. So if we configure default at least 1, then it's going to participate what? DR election process. If we configure priority is 0, it is not going to participate in a election process anymore. Okay. So highest priority value is what? 255. In between, you can use any number. 0 means no election process. 1 means is eligible for election process. I can compare to all routers. If all routers priority is same, then highest IP address will come in the picture. So there is a point here is showing here clearly. Router with highest OSP of priority will be become what? DR, and the router with a second highest priority will become what? BDR. And all routers default priority is 1. Right, guys? DR, BDR, election process only in OSPF in LAN topology, not in the WAN topologies. Okay, the LAN. Yeah, Ankita, manually we need to configure DR and BDR priority values. Let me show you the practically how to design these and how to configure DR BDR action process. One, five routers in LAN. Connections are okay. We configure it. router. Host name R1. Interface path Ethernet. IP address 10001. No shutdown. Network 10000. Wildcard mask 0.255.255.255 dot area 0. Same configuration for all routers, right? Let me copy this configuration. Second router. Host name R2. Interface fast Ethernet 0/0. IP address 10002. No shutdown. Router OSP of 456. OSP is configured. The configuration. Fast Ethernet 0/0. IP address 10003. Router OSP of the configuration. And let me configure the host name also to avoid the confusion. And there are R3. Host name is what? R3. R4 router. R4. Router OSP of process ID and configuration. Last router configuration. Configuration mode. Host name R5. Fast Ethernet. IP address 10005. Router OSP of process ID and OSP of configuration. Just cross ID. Numbers are cross ID. You can use any number. My example 1, 2, 3, 4, 5, 6. Some numbers have been used. You can use any number as a cross ID. Okay. Now OSPF is being configured in all routers. Like all routers are connected in a switch. This topology. Let you tell me, guys. Out of 5 routers, which router will be the DR router now? Like default, all routers priority is 1. We didn't configure any priority right? 10.5 will be DR router, right? Why? Why? Because so when priority is same, highest IP address will be what? DR router. But R5 is not a DR. Let me check which is a DR router. I log in R4 router. Show IP OSPF neighbor command. If I see neighbor here, yes. 10005 is a what? DR. It's actually 10.4 can be a BDR, right? But showing here is what? BDR is a 10001 is a BDR. Why? PRI priority. All routers are priorities what? 1. State. DR other two-way state. One is a 10.1 and 10.5 is a full state. BDR, DR. Here, one very important point here. What OSPF is doing is, so first priority. First, what OSPF is doing is, it won't verify the like priority values and highest IP address. We configure OSPF in R4 first. Now R4 is the DR. We configure OSPF in R1. R1 is the DR. Like in which router we have configured first in OSPF, that is a DR router. Maybe lowest priority or lowest IP address also. Which router have configured OSPF first, that is a DR router. All routes at the same time you have to configure. It is not possible. What I'm doing is I'm reload the switch. The switch is reload. All routers are being restarted once again. Now let me check. Show IP OSPF neighbor command. Neighbors are not yet formed. Like let me keep verifying on it. Show IP OSPF neighbor. Now I can get the states, initial state, two-way. Showing is what? Init, initial state. Like start. Show IP OSPF neighbor. Now exactly can get DR full. Like DR is what, guys? 10.5 is a DR router and 10.4 is a BDR router. Remaining all routers are what? DR other routers. So now OSPF, DR and BDR election process based upon what, guys? Here now router ID, neighbor ID commands, right? Based upon the IDs. But I don't want 10.5 is a DR. I don't want 10.4 is a R4 is a BDR. I want to make R1, R2 as a DR, BDR. Then what want to do? Change the priority. Configure the priority. Let me configure R1 priority. Let me show you the configuration. Interface fast Ethernet 0/0 IP OSP of priority. IP OSP of priority and priority have configured 250 for R1 router. Save the configuration. For R2 router, interface fast Ethernet 0/0, IP OSPO, priority is a 200, R2X 200, save the configuration. Now once again, let me restart, switch once again. Like whenever if you do any changes, priority changes, we have to reprocess the OSP once again. Then only actual verification is done. If it's not restarted, if it's not reprocessed, so previously R5 is a DR, right? The same thing will happen then. Once if your routers are being restarted, reloaded, or OSP is reprocessed, then new values will take effect. Okay, guys. Yeah, technically we have one command is there without restarting. Is in router privilege mode have used clear IP ISPO process. This is the command. So if we execute this command, only OSPP is only restarted, not the entire router. But what we do now, just we have to what entire router, right? But instead of that, if we use command here, clear IP OSPO process. Now in RT router, only OSPP is reprocessed. Okay, this is the best command. Clear IP OSPO. So IP OSP of neighbor. Enter. See 10.0.0.1. 250 is the priority. DR is. And 10.0.0.2 highest, second highest priority 200. BDR. This is how DR BDR election process is being done. These are the verification commands and DR election process. You can copy it clearly. Copy it. Only fast Ethernet. See, OSP when LAN means what? Only for LAN ports. No other interface. In topic is OSP when LAN, then fast Ethernet only. Ports are connected to wide area, right? Okay, guys. Right. We successfully completed dynamic routing product. Dynamic routing is being finished. once again on types of dynamic routing protocols. Dynamic routing are two types. One is IGP and EGP. IGP types are what? Distance vector protocol, link state protocol, distance vector protocol, link state protocol, and advanced distance vector protocol. Distance vector protocol is RIP, OSPF, EIGRP. EGP is a path vector. Is one and only protocol is BGP protocol. RIP, OSPF, EIGRP. Out of these, we clearly discussed about RIP and OSPF, right? So as per your knowledge, can you tell me out of two protocols, which protocol has a more advantages and which is the best one, RIP or OSPF? OSPF, why? Let me clearly discuss about, once again, the three protocols clearly. Can you hear me all of you clear? Right, let me explain clearly all three protocols. I've prepared one chart. The first one is DVP, Distance Vector Protocol. RIP, Routing Information Protocol. The open standard means support for multiple vendors. So RIP you can configure in Cisco router, D-Link router, Juniper router, MyPo, like multiple vendors, not only in Cisco. The open standard, right? Like who developed the RIP protocol? The scientist name and algorithm name is Bellman 4 algorithm. RIP is a classless routing protocol, which is RIP version 2. It can support for subnetting. And RIP will find the best route based upon number of hop count. We call it as a each and every protocol has a metric values. RIP metric is a hop count. And maximum is 15 hops only. If you 16th hop, your network is unreachable. And RIP use multicast address by using 224.0.0.9, the multicast address. Updates. What type of updates in RIP is a periodical updates. Update timer is 30 seconds. Invalid is 180. And flush timer. Flush timer is what, guys? RIP can support for load balancing when equal hop count. When hop count is equal, can do what? Load balancing, and administrative distance is 120. Clear? Next protocol is a link state protocol. OSPF, open standard, open shortest path first, is also open standard. SPF algorithm, support for subnetting, classless routing protocol. Metric of OSPF is a cost. Nearly OSPF protocol we have discussed about 3 days, from Friday, Saturday, and today also we'll continue with the OSPF only. Like all about OSPF terminology clearly have discussed. OSPF cost values, OSPF tables, and OSPF DR, BDR actions, OSPF in LAN. Like all about OSPF mostly discussed. And OSPF support for what? Unlimited. OSPF multicast address 240.0.0.5 and 6. Both updates. Incremental when there is update, when there is a change, then only. Hello timers are 10 seconds and invalid, like hold down timer. Dead timer you can say. The whole OSPF terminology. Dead interval timers are what? 40 seconds. Load balancing also will do the OSPF when equal cost. The cost formula we clearly discuss. Reference bandwidth by interface bandwidth. and admission distance is what? 110. About difference between RIP and OSPF, and let me see one more protocol is EIGRP. Actually, is out of syllabus, and still we'll discuss a brief introduction. Enhanced Interior Gateway Routing Protocol. I repeat once again. Compared to RIP, OSP has more advantage, right? We have decided finally OSP is a best. But if you compare to OSPF, EIGRP has a more advantages. You know what? EIGRP also open standards, GL algorithm, classless routing protocol, support for subnetting, and metric of EIGRP is a composite metric. So what is a composite metric actually? RIP will find the best path based upon what metric? Only one metric weight, only one metric value, that is what? Hop count. OS will find the best route based upon what? Cost, only one metric weight. But EIGRP has a 5 metric weights, 5 metric values. And EIGRP terminology we call 5 K values, K1, K2, K3, K4, K5. RIP is only one, which is hop count. OSPP is only one, which is bandwidth, I mean cost. But EIGRP can find the best route based upon the 5 metric weights, which is a K5 values. K1 is bandwidth, K2 is a load, K3 is a delay, K4 is a reliability, K5 is a MTU. These are all parameters will included. Anyhow, EIGRP by default can find the best route based upon the 2 metric weights, which are K1 and K5. Maximum is 255 hop count, and multicast does 240010. What type of updates in the OSP of the same updates in EIGRP also is incremental. When there is a change, then only update. But compared to RIP, OSP is fast protocol, and compared to OSP of EIGRP is a very fast. Like hello packets, like hello timers are 5 seconds. Invalid 15 seconds. Within 50 seconds, if the neighbor is not responding, no more. Neighbor is down. EIGRP up to OSP up to what? 40. But EIGRP is only 15. So within 5 seconds, neighbor is been formed. Very good advantage of load balancing. RIP OSPF will support for load balancing when equal hop count and equal cost only, but EIGRP protocol only support for equal and unequal cost load balancing. Finally, three protocols RIP, OSPF, EIGRP. Which routing protocol has a more advantages? You tell me guys now. Which is the best? Of course, EIGRP only. Because EIGRP is a composite metric, number of metric weights can support. Moreover, EIGRP can support very large number of hop count. Even hop count is very large, like 255 is a very large number, right? In OSPF support for unlimited, but what we are doing is we are dividing to area concept. In one area, how many routers are recommended? 40 to 50. So means again we are making what 50 only, but EIGRP can support what 255. No problem at even incremental updates when fastest protocol. Load balancing is supporting for equal and unequal cost load balancing also. So compared to OSPF, EIGRP has a more advantages. You know, EIGRP we can call as a hybrid protocol. Advantage of RIP, advantage of OSPF, mix of two protocols is EIGRP. But in the real time, which protocol we use? At present, industrial, like which protocol we use? RIP, OSPF, or EIGRP? OSPF, but we have compared to OSPF, EIGRP is a more advantage, right? Then why can't we use EIGRP? Because of EIGRP, all the protocols is not purchased, right? To purchase. The problem is here. EHRP protocol was Cisco protocol. It was like before 2013, 2015, I think so. 2015 before it was a Cisco protocol. It will works only for Cisco devices. Present it is open standard, but before 2015 is a only working for Cisco devices. So recently it's been open standard, but before 2015, EHRP can work in only which routers, guys? Only for Cisco. Then before 2015, which protocol is based? OSPF, right? So like all the IT companies, all the banking sectors, like to maintain all Cisco routers, they have a 14K Cisco routers to maintain for SBI to support for EHRP, but it won't happen in real time. 90% of we use only Cisco routers, but 10% we use what still? Like HP routers, MIP routers, D-Link routers also, like other vendors also. But other vendors EHRP lot support before 2015. We'll go for what? OSPF. Now it is open standard means, so to support for EHRP, again entire your office infrastructure, like again your protocol has to change completely. We continue with OSPF, no problem, but if EHRP is open standard now, so we want to update means the whole topology of your organization have to change, right? It's very difficult. Even if we change, so we are very familiar, our network team guys is very familiar with what OSPF. If any issues happens, they can easily understand it. No, OSPF, Cisco is given the like a privilege. Cisco is given the license for all the vendors. Exactly after 2015. Yes, so Cisco in the open source is almost as the open source. These are major differences between all the protocols, three protocols. See, this is my home router R1 to switch to end users. See, let me discuss clearly about one more protocol where we use BGP. Out of syllabus, but let me brief introduction. At least we can get the knowledge, right, where we use this BGP. R1 router. R1 is connected to ISP router. Okay, guys. So my ISP is a Act Fiber in Hyderabad. Connected. Now I'm trying to reach one of the web server. Example, Google server. So you tell me, guys, now from in Hyderabad, Act Fiber router is directly connected to Google server. It's directly connected to Facebook server. ACT broadband is connected to one more service provider. Example, BSNL. Now BSNL is connected to an international service provider, let's say Airtel. Now Airtel to one more international service provider, which is VSNL. Now VSNL to local routers, local router to switch, and switch to Google server. Somewhere is connected. The topology, right? Now if we take the ACK service provider, ACT broadband. The complete whole ACT broadband has only one router, guys. Has only one device? No. Like in Amirpet area, one router. Like Banjar Hills area, one router. Hyderabad, like in Andhra Pradesh, in Telangana, one. They have their own topology. ACT broadband has what? Own topology, right? Okay, 1, 2, 3, 4. So these all are ACK fiber routers. 1, ACK fiber 2, ACK fiber 3, ACK fiber 4. Is the name A1, A2, A3, A10, and A100. The BSNL router. So BSNL also has their own network, right? BSNL 1, BSNL 2, BSNL 3, BSNL 4, B1, B2, B3, B10, and B100. For Airtel routers, 1, 2, 3, A1, A2, A3, A10 is A100. The devices are connected, like VSNL and VSNL to some router. So from this is your computer, end user computer. Now user is trying to open the Google server. Now what end user is doing is data traffic is being generated. Now data traffic will come to router 2 ACK fiber router 2. So this data packet is giving exchange to which one? BSNL. So BSNL to Airtel, Airtel to BSNL, BSNL to Google server, right? So means user traffic is reaching the destination server by using only one service provider or multiple service providers. Many, right? Like ACK fiber A1, A2, A3, A4. So these all routers, how they are communicating, how they are connected. For example, let's consider this is also A4, A4 routers. Now ACK fiber, number of many routers, how they are communicating. Now A1, A2, A3, A4, A10, A100 routers are available, right? So these all ACK fiber routers will belongs to one group, right? One administration. So number of routers is belongs to one administration. So this technically we call autonomous system. AS. One autonomous. Similarly, BSNL network B1, B2, B3, B10, right? B100. Like complete BSNL network topology, this all router will comes under one administration. So number of routers is belongs to one administration. We call it as what? Autonomous system. One other another this is. Like similarly for Airtel also one more another autonomous system. Yes. Like VSNL. So each and every autonomous system is being identified using one number, one unique number. If it's ACK fiber, AS number 100. If it's BSNL, AS number 200. If it's Airtel, AS number 300. VSNL, AS number 400. Okay. Now user traffic is being generated. So within the same autonomous system, like A1, A2, A4, these all routers autonomous system number is what? 100. So within the same autonomous system numbers to communicate, we have to make use protocol called IGP protocol. So within the same service provided to enable communication, either you can use RIP, either you can use OSPF, either you can use what? EIGRP. So IGP protocols used for what? Within autonomous system. Within the same autonomous system to communicate, we use what? Interior gateway protocols. Similarly, BSNL 1, BSNL 2, BSNL 3, BSNL 4, like all BSNL routers belongs to which AS number? AS number 200. Like BSNL to BSNL to communicate, we have to make use which routing protocol, guys? IGP. IGP, right? Interior gateway protocols. Airtel 1, Airtel 2, Airtel 3, like Airtel, 100 routers or 200 routers or 1000 routers within the same autonomous. We use which routing protocol is a IGP. But now, user traffic to reach destination, your user data traffic is reaching destination by using only one autonomous or number of autonomous. Like first, your data come to A4 router. A4 is hand over to A100. A4, A100 both can communicate, both can exchange the routing information by using which routing protocol? IGP. Why? Because both are belongs to what? Same autonomous system. Now A100, Act Fiber A100 is giving the routing information to B100. Means AS number 100 router is giving the routing information to AS number 200. So you major try to understand autonomous system numbers. Act Fiber, BSNL, Airtel is my example. Just for example only, but technically you have to understand different autonomous systems. Like AS number 100 want to extend the routing information to AS number 200. Now, one and only protocol that is exterior gateway protocol, which is what? BGP. Exactly. Perfect. So now you tell me guys, when and where we use BGP protocol. So BGP protocol we use to exchange the routing information between the different autonomous systems. Within the same autonomous systems, we use IGP. It can be RIP, it can be OSPF, it can be EHRP. So based upon your requirement, you can use any one protocol, which is IGP. But when your routing information being exchanging for different autonomous systems, we have to use which routing protocol? BGP, right? Border Gateway Protocol. Now BSNL 1, BSNL 2, BSNL 3, BSNL 4. Like all BSNL routers can communicate by using which routing protocol? IGP. Now B100 is giving the routing information to okay A100. B100 is giving the routing information to A100 by using which routing protocol? To understand here, users are reaching internet. The whole internet is working. A backbone of internet protocol, which is what? BGP. So BGP stands for what? Border Gateway Protocol. Where we need to configure the BGP means not in the all routers, only border routers. I mean A100 router and B100 router, Airtel 100 router, VSNL. Only the border routers if we configure BGP enough. In the border routers, not only BGP, have to configure what? IGP protocol also. A1, A100 can communicate via what? IGP. A100, B100 will communicate via what? BGP. Is the logic. If someone is asked the question, you can able to answer it. So where we use BGP? So what is exactly BGP? The border gateway protocol generally we use to exchange the routing information between the different autonomous systems. me show you one. Okay. Connected networks. Mumbai, Delhi, Chennai, Kolkata, Bangalore, Hyderabad, like India wide. A website called National Internet Exchange of India. We see here. First customer is Bharti Airtel Limited. Name of the service and the ACE number 9498. Autonomous system number 9498, which present Bharti Airtel is using. Next customer, second one is BSNL 9829 using IPv4 and IPv6. Some devices are not using. So this is the heading. If you see the heading here, where these networks are connected, connected networks at Mumbai location. Okay. So in Mumbai, Bharti Airtel Limited, ACE number is 9498. Let me check in the Delhi. On Delhi. The Delhi also, Bharti Airtel, ACE number is what? 9498. Let me click on Chennai. Now, connected networks at Chennai. Where is Bharti Airtel? Let me. Where is the Bharti Airtel? Seventh. Okay, right. Seventh one. 9498. Thank you, Pradeep. See, the three areas. Mumbai, the same number, same autonomous system I'm using. Delhi and Chennai also. Let me check in Kolkata. Till 39498, same number, same autonomous, like same service provider, right? Same autonomous, same number. Case number 949. We'll go for the Bangalore. Bangalore, Pipetail, CV Technology, Citycom, Dishnight, no Airtel. In the Hyderabad. Even the Hyderabad, Excel Media, Pioneer, and Railtel, Tata Television Services. No Airtel in Hyderabad. Hyderabad, no Airtel. Guwahati, no Airtel. So, do you have any knowledge on NIC? Have you heard about NIC, guys? National Informatics Centers. So, recently, NIC has been announced. There are some openings for network engineers. Yeah, government undertakes. So, recently, it's been announced. Have, notification has been released. So, for interested and having eligibility, you can try to apply them. It is maintained by central government. NIC. NIC is going to provide the network services for all government sectors, state government and central government. Example only, right? Like when ACE number 9498 is trying to exchange the information for, like, general example, SBI network, HDFC, have one network. So many banks is there. Like all SBI network, they can communicate by using which routing protocol? IG. All bankings are working together, SBI, HDFC, right? By using SBI card, you can withdraw the HDFC also. Like SBI and HDFC, how they can communicate? By using which routing protocol? AG. Like simple example. Clear, guys? Okay. And one more thing is, let me explain one small topology. Static routing. Admission distance is what? 1. For RIP, 120. For ASPF, 110. EHRP, 90. So what is exactly this admission distance? What is this? What is 1 and what is 120, 110, 190? What is this? Any idea? Yes, please. Reliability of routing protocol. Okay. What does it mean? Reliability of protocol means what? A good point actually. We have only topology. Right, guys. Understand the topology clearly here. The router is come to B, C, D, the 3 links. First link, serial 0/0, speed is 10 Mbps. Second link speed is 80 Mbps, and third link speed is 70 Mbps. Now, from router A LAN, I'm trying to reach H LAN. Router H LAN is my destination. In A router, if I configure static routing, Now, as per static routing, which is a best path? Any more answers? Perfect. Perfect. Pradeep, you're perfect, right? Admin can define. Very good. See, someone is telling is ABH. So why ABH? Someone is telling is that ACEH, like 80 Mbps. Like static routing, best path selection by administrator. Admin can define. Admin can consider maybe it's based upon the speed or based upon like a reliability, based upon the security, based upon the faster. Can be any parameters, right? So we can't say so and so the speed, so and so like that. Defined by what? Administrator. Admin can find the best path, secure path, security, reliability. The more parameters can consider. Example, as per static routing, 0/1, 0/1/0 is a best one. Is via ADFGH. It's maybe more secure, maybe it's a more faster, no traffic on here, no dropping, no traffic are dropping here. Everything is good. So we have defined serial 1/0 is a best path as per static. The same router, if I configured RIP protocol, now which is the best one, guys? Based upon RIP, which is the best one now? Tell me. Serial 0/0 ABH. Why? Based upon what? Hop based. Serial 0/0. RIP selling is that, yeah, this is my base source because I have a less hop count. Okay. The same router have configured OSPF. As per OSPF, which is the best path? Serial 0/1. Why? Now OSPF will find the best path based upon what? Bandwidth, speed, right? 0/1. So OSP will find the best path based upon only the bandwidth, no hop count. Right. Now, in one router, have configured static routing, have configured RIP, have configured OSPF, like multiple routing protocols are configured in one router. Now, LAN traffic is being generated, user traffic is started. So, this traffic will come to router. Now, what router will do? So, this data traffic to reach the destination, router H, now router will consider which routing protocol is a best now. What static routing is doing is router A send the traffic via 1/0. It is my secure path. Same time RIP selling is that no. Router, you use my route. This is my less number of hop count. You can use what? This is my best route. The same time OSPP selling is that no. You can use this is my very high speed link. So if you go via like this, you can reach very fast. So use this router. This link is a best path. So three routing protocols is telling the three different waves. So router A will get confused. So which routing protocol is telling the right information? So which routing protocol I need to trust? Which is giving the good information, right information? Which is giving the proper information? Which is giving the best information? Get confused, right? So what A is doing is, so don't tell your base paths. Now first tell me your administrative distance. So now A will decide. So when we have running with a multiple routing protocols, now router will decide which is the best one means based on what? Administrative distance of the protocol. So static routing AD value is 1, RIP is 120, OSPF is what? 110. Now what A is doing is lesser the AD value, higher the priority. So in the short form, simply you can say ranking of the protocol. Rank 1, rank 120, rank 110, which is the best rank. So based upon static routing advantages, static routing features, admin value is what? 1, always is 1, right? So what A is doing is your traffic can reach via serial 1/0 is a best. So now we can understand what is exactly administrative distance is. Administrative distance is a reliability of the protocol. Lesser AD value, higher the priority. Okay. So now if a static is being removed, if I have removed static routing out of two protocols, which protocol will work now? OSP will come in the picture. So even you can practically you can do it. So do one thing. So take this topology. So generally this topology we are configuring, right? In this topology, so first you configure RIP in 3 routers. And don't remove RIP. On top of RIP, if you configure OSP in 3 routers, the routing table you can see only RIP, OSP. RIP will not come in the picture. Because RIP AD value is 120, OSP AD value is 110. On top of that, if you configure EHRP, now EHRP will come in the picture. Because EHRP 90, right? So finally, in the 3 routers, if we configure static routing, which protocol will work, guys? Uh, Now we have the good information about dynamic routing complete, where we use IGP, where we use EGP, and RIP, AD values, or history of GRPs about dynamic routing. Any doubts, guys? Yes, please. Mustafa. Show IP routes. In the routing table, show IP route to present OSPF is working, right? Show IP protocol sequence. OSPF is working. On top of OSPF, router EIGRP, some ACE number 100, network 60000, network 80000, network 192.168.2.0. Branch office 1 EIGRP is configured. Even in branch office 2, router EIGRP ACE number 100, network N00, network 63000, network 70000. Head office also configured EIGRP, and the last router branch 2 configuration mode, router EIGRP is number 100, 192.168.3.0, network 70000, 8000. In the three routers, we have configured which routing protocols now. Already OSPF is running, and on top of that, I have configured what EIGRP. OSPF ACE number is 110, EIGRP ACE number is what 90. Now, which routing protocol come in the picture in the routing table? EIGRP. You can see here there is no O in EIGRP in OSPF place. We can see here D. D indicates EIGRP. Real algorithm. Okay. Okay, guys. So actually, I need to start today switching classes, but it's been time out. Problem. Try to practice on OSP of DR, BDR, OSP in LAN, and try to run multiple routing protocols in routers. First configure RIP and configure OSP of, and finally configure static. You do some configurations in router. Try to practice more hands-on in dynamic routing protocols. If once you've finished, and tomorrow freshly we start about switching class. From tomorrow onwards, switching up to 4 sessions. Once switching is done, I'll go for some advanced routing protocols like internet related topics, which is default routing, NATing, some security related topics. Let me continue with our session.
Clear, guys? Any doubts?
Number of. By using one public IP address, we can connect number of private IP addresses. Nearly 60,000 connections we can do with one public IP address. We can map one public IP address to 60,000 private IP. Okay. There is a technology we call port address translation. It's one of the type of mapping. Any more doubts regarding the three protocols like dynamic routing protocols and RIP or ESP, short and BCP? All right, I'm going to end the meeting now. Still, if you have any doubts, and while you're practicing the dynamic routing protocols, you are facing any issues, right away can text me on WhatsApp. I will try to. Right. Going to end the meeting. Once again, thanks to all of you. Your job is hands-on practice with all the time. Once you start doing the practice, and phase more, you can, more doubts will come in the picture. Start doing the practice. Yes, we just end the session now. Yes, Minhas, I will share the links to you. Wait for a minute. App manual. Let me send links to you. These are the links you can use of course presentation and lab manuals. Like this. Have you copied? You share the link. So first copy the links. I'm going to end the meeting.